Hello students, today we solve some complicated example in chapter number 4 definite integration. Now the first example is integration 0 to 3 x into square bracket x, but here square bracket x is the greatest integer function, that means not greater than x. For example, suppose in square bracket 5.3, then its value is 5, greatest integer but less than this 5.3, which is the 5. In this way solve this example. The last year in function we draw the graph of the step function, that is the step function means greatest integer function. By using this technique, we first split this integral as integral I is equal to 0 to 3 x square bracket x greatest integer function into dx. Now from 0 to 3 there are 1, 2, 3, 3 integers, 0, 1, 4 integer, 0, 1, 2, 3. Now split this in this way. First 0 to 1 x dx plus 1 to 2 x dx plus integration 2 to 3 x dx. Now by using the property A is less than C is less than B, only one C lies between A and B, but in place of C we take n points, that is C1, C2, C3. Similarly in 0 to 3 1 and 2 are two integer, therefore we split this integral in this way. Now then write integration of 0 to 1 x. Then what is the value of 0 to 1 of this greatest integer function? This greatest integer function is less than 1, that is integer is only 0 dx plus 1 to 2 x, the greatest integer function or greatest integer less than 2 is 1, or its value is, not take square bracket, open bracket, 1 dx plus 2 to 3, the greatest integer less than 3 is 2, it is x into bracket 2 dx. Now first integral is 0 into this 0 plus integration of 1 to 2 x dx multiply by 1 and value does not change, plus twice take outside the integration 2 to 3 x dx is equal to 0 plus its integration is x square divided by 2, limit is 1 to 2, plus twice again the integration of x is x square divided by 2, limit is 2 to 3, is equal to we can add the 0 in any term, value does not change, then I cannot write here 0. Then upper limit is 2 square 4 divided by 2 minus lower limit 1 square 1 by 2 plus twice. Here upper limit is 3. 3 square is 9 divided by 2 minus lower limit is 2. 2 raised to 2 is 4 divided by 2 is equal to, in first bracket 4 minus 1 is 3. 3 by 2 plus twice. Here also denominator same. 9 minus 4 is 5 divided by 2. This 2 and 2 cancel. 3 by 2 plus 5 is equal to 3 plus 5 into 2 is 10 all divided by 2. That is 13 divided by 2 is the answer. Now most important point is the concept of greatest integer function, that is the steps function. The value of this function is greatest integer but less than x. Now, which is the final solution. We apply the property A to B lies between C or C1, C2, 0 to 1, 1 to 2, 2 to 3. In this way, we solve these problems by using the property. Now, next example, again, which is a different type of example. Modulus of x minus 2, limit minus 2 to 3. Now, first find the value of modulus of x minus 2 is equal to, there are two possibility, minus bracket x minus 2 if x minus 2 less than 0, that is x is less than 2, and mod of x minus 2 is equal to positive x minus 2, here sign positive, only positive, here negative, if mod x minus 2 is greater than 0, that is x is greater than 2. That means we split the integration I is equal to, here the limit start from minus 2 to 3, but if x is less than 2, then its value is negative, otherwise its value is positive. That means if we take its value is negative, lies between minus 2 to plus 2. Minus 2 to plus 2, its value is minus bracket x minus 2 into dx plus integration of, from x is greater than 2 to 3, its value is positive, that is x minus 2 into dx is equal to integration minus 2 to 2 plus 2, its value is minus x plus 2 dx plus integration of 2 to 3 x minus 2 dx. Now again we split the integral minus 2 to 2 and then 2 to 3, because there are two possibility of modulus, plus or minus. If its value is positive, then this is the greater than 0, and negative less than 0. That means this modulus value is negative if x is less than 2, value is positive, x is greater than 2. From 2 to 3 its value is positive, from minus 2 to 2 its value is negative. Then take its integration. Minus x square divided by 2 plus 2x, limit is minus 2 to 2, plus x square divided by 2 minus 2x, limit is 2 to 3. Now take upper limit minus lower limit by using fundamental principle. The upper limit is 2 square, that is minus 4 divided by 2. 2 into 2 is plus 4. Substitute value minus 2. Minus 2 square is also plus, that is 4. Or we write square bracket and then substitute these values. Minus 2, that is minus 4 by 2, and here 2 into minus 2 is minus 4. Upper limit 2 square is 4, 4 divided by 2, plus 2 into plus 2, 4. Lower limit minus 2. Minus 2 square is positive, minus 2 square is positive, this minus sign divided by 2, minus plus 2 into minus 2 is minus 4, plus here again upper limit 3 square is 9 divided by 2, minus 3 into 2 is 6, minus 2 square is 4 divided by 2, minus 2 into 2 is 4. Now simplify this. Minus 2 plus 4 minus 2 minus 4 plus 6 into 2. 6 into 2 is 12, minus 12, and plus 9 minus 3 by 2, minus 4 into that is 2, 4 divided by 2 is 2, 2 minus 4 minus 2. Then its value is first bracket plus 2 minus 6 minus 3 by 2 minus plus 2. 2 plus 6 plus 2 minus 3 by 2. Last term negative. 2 plus 6 plus 2 is 10 minus 3 by 2 is equal to 20 minus 3 divided by 2 is equal to 17 divided by 2 is the final answer. Now again we apply the property A less than C less than B. Also use the property of modulus. There are two possibilities, positive and negative. If this value is negative, less than 0, its value is negative. X minus 2 is positive, its value is positive. Now then we take third example. Now this example is, I will solve here but only explain. The last property is integration of minus pi by 4 to pi by 4 x plus pi by 4 divided by 2 minus cos 2 dx. If limit is minus a to a, then first check the given function is odd function or even function. But in place of x we substitute minus x. This function is not odd, not even. But numerator consists two terms, x plus pi by 4. First step, I write separate denominator. X divided by this denominator plus pi by 4 is constant. Take outside the integration. 1 divided by this denominator. Then I write integration is two parts, I1 plus I2. Integration I1, that is this I1 plus constant term pi by 4 integration I2. And first solve I1. I1 is equal to minus pi by 4 to pi by 4 x divided by 2 cos 2x. In place of x, we substitute minus x. F of minus x is equal to minus x divided by 2 cos of minus 2x. Cos function is even function, then its value does not change. But numerator minus x, then minus of, we get again f of x. That means f of minus x is equal to minus f of x. Therefore, f of x is odd function. If f of x is odd function, then its integral value is 0. That is I1 is 0. One part is completed. Now consider second part. I2 is again limit minus pi by 4 to pi by 4. 1 divided by 2 cos 2x. Then again f of x is 1 divided by 2 minus cos 2x. Substitute value in place of x minus x. Numerator is constant. Denominator, the value does not change. We get again f of x. That means f of minus x is equal to f of x. Therefore, f of x is an even function. If the function is even, then this integral is limit change. Minus a to a, instead of minus a to a, twice 0 to a. That is 0 to in place of a here, pi by 4. Twice pi by 4, 1 divided by twice cos 2x. Now we solve this second integral. Now here the I2 solve in this way. I2 is equal to 0 to pi by 4 divided by 1 divided by, instead of cos 2x, I write cos 2x, the value of cos 2x. There are different formulas. First formula is cos square x minus sin square x. We apply this formula cos square x minus x square x. Then we get twice 0 to pi by 4, 1 divided by 2 minus cos square x minus minus plus sin square x. Now which is the standard form? If integration 1 divided by a cos square x plus b sin square x plus c, then divide numerator and denominator by cos square x or sin square x. But we apply this dividation cos square, because sin square divided by cos square is tan. We apply the tan and sec formula. The students are alternative. Some students can be divided sin square also. In place of tan square, we get the cot square and cosec square. Then apply this formula. Now in numerator 1 divided by cos square, sec square. 2 divided by cos square, 2 sec square. Minus cos square divided by cos square 1. Sin square x divided by tan square x, tan square x. Then in place of sec square, we convert in the form of tan. 1 plus tan square is sec square, but coefficient of sec square is 2. Then multiply this. It is sec square x is equal to 1 plus tan square x, multiply this by 2. 2 plus 2 into tan square x minus 1 plus tan square x. Then we get sec square x divided by 3 tan square x plus 1. Take 3 common, then 2 by 3 integration 0 to pi by 4 sec square x divided by tan square x plus 1 by 3 dx. Now again, which is the different form, that means we apply the 3 out of 3 one methods, that is as substitution tan, its derivative sec square, that means substitute tan x is equal to t, then we get the numerator. Then after change the variable, the limit also change. As x tends to 0, t tends to 0. Tan 0 is 0. X tends to pi by 4, t tends to 1. That means the variable t belongs to 0 to 1. Change the limit, then 2 to 3. Also, if we take its derivative, then sec square x dx is equal to dt. That means numerator is dt. 2 by 3, 0 to 1, dt, t square plus 1 by 3, 2 by 3, 1 divided by t square. Now 1 by 3 is right in square form, 1 divided by root 3 bracket square. Then, which is the standard form, 2 divided by 3 into its integration is 1 divided by x square plus 1, that is 1 by a into tan square x by a. A is 1 by root 3, 1 divided by 1 by root 3, that is a. Tan inverse of x is t divided by a is 1 by root 3. Lower limit, upper limit. Now continue this. Is equal to 2 by 3. The upper limit is 1. 1 divided by root 3 means root 3 into tan inverse of t divided by 1 divided by root 3 t. First simplify this, and then the limit is 0 to 1 is equal to 2 by 3. Take upper limit is root 3 tan inverse of root 3 into 1 minus 2 by 3 root 3 into tan inverse of root 3 into 0 is equal to 2 by 3 bracket 2 by 3 bracket root 3 into tan inverse root 3. Tan inverse root 3 is pi by tan 60 degree is root 3 and tan 30 degree is 1 by root 3. Therefore, here tan inverse root 3 is pi by 3 minus 2 by 3 into tan inverse of 0 is 0, 2 by 3 into 0 is equal to 2 into root 3 pi, 2 into root 3 pi divided by 9. The value of I2. Now we write I is equal to I1 plus pi by 4 pi by 4 into I2. Is equal to 0 plus pi by 4 into I2 is 2 root 3 pi by 9. Root 3 divided by 2, pi into pi, pi square 9. Root 3 divided by 2, pi square root 3 into root 3, 3 into 3. In this root 3 cancel, is equal to pi square divided by 3 into 2 is 6 into root 3. हे फायनल आन्सर जे आहे ते किती मिळालं, पाय स्क्वेअर डिवायडेड बाय 6 इंटू रूट 3 इज द फायनल आन्सर. एवढं जरी ठेवलं तुम्ही, हे रूट 3 जे आहे 9चं आपण डिवायडेशन कसं केलं, 3 इंटू 3 in place of 3 root 3 into root 3. 1 root 3 cancel, pi square divided by this 3 into this 2 is 6 and remaining root 3 is the final answer. In this way we are solve some complicated problem in definite integration by using the properties as well as by using the definite rule, integration by parts, partial fraction, substitution methods. So this fourth chapter is today completed. Thank you.